Designing a production planning and control (PPC) model based on stock-in-hand forecasting involves predicting inventory levels, managing production schedules, and optimizing resources to ensure sufficient stock is available to meet demand. Here's a step-by-step guide to help you design an effective PPC model for stock-in-hand forecasting using AI. Pradeep K. Suri. Author and researcher. 1. Define the problem. Clearly define the PPC problem related to stock-in-hand forecasting. Specify the scope, such as the type of products, production processes, and the key metrics you want to predict, example stock levels, lead times, reorder points. 2. Data collection. Gather historical data related to stock levels, sales, production quantities, supplier lead times, and any relevant factors influencing inventory levels, example order history, seasonal demand. 3. Data pre-processing. Clean and pre-process the data. Handle missing values, outliers, and encode categorical variables. Ensure that the data is in a format suitable for machine learning. 4. Feature engineering. Create meaningful features from the raw data. Feature engineering can include time-based features, lag features, previous stock levels, and variables that capture external factors affecting inventory, example promotions, supplier delays. 5. Data splitting. Split the data into training, validation, and test sets. The training set is used to train the model, the validation set helps tune hyperparameters, and the test set is for final evaluation. 6. Model selection. Choose an appropriate machine learning or deep learning model for stock-in-hand forecasting. Common choices include time series models, example ARIMA, profit, regression models, example linear regression, and neural networks, example LSTM, GRU. 7. Model training. Train the selected model using the training data. Set the target variable as the metric you want to forecast, example stock levels. Optimize the model using appropriate loss functions and evaluation metrics. 8. Hyperparameter tuning. Fine-tune the model's hyperparameters using the validation set. This may involve adjusting learning rates, batch sizes, regularization parameters, and network architecture, if using deep learning. 9. Model evaluation. Evaluate the model's performance on the test set using appropriate evaluation metrics. Common metrics for stock-in-hand forecasting include mean absolute error, MA, mean squared error, MSE, root mean squared error, RMSE, and R squared, R superscript 2. 10. Model interpretation. Analyze the model to understand how it makes stock-in-hand forecasts. Identify which features have the most significant impact on inventory levels and production schedules. 11. Deployment. Deploy the PPC model for stock-in-hand forecasting in a production environment. Ensure it integrates with your inventory management systems and data sources. 12. Monitoring and maintenance. Continuously monitor the model's performance in the production environment. Retrain the model periodically with new data to keep it accurate and up-to-date. 13. Post-deployment analysis. Analyze the model's predictions in a real-world production setting. Compare the forecasts to actual stock levels and gather feedback from inventory management experts to identify areas for improvement. 14. Scalability and optimization. Ensure that your PPC model can scale to handle varying stock levels and changing production requirements as your business grows. Optimize its efficiency and resource utilization. 15. Consider external factors. Be aware of external factors affecting stock levels, such as market demand fluctuations, supplier performance, and economic conditions. Incorporate relevant external data sources into your model. 16. Documentation. Document the entire process, including data sources, pre-processing steps, model architecture, and hyperparameters. This documentation is valuable for future reference and model maintenance. A well-designed PPC model for stock-in-hand forecasting can help optimize inventory management, reduce carrying costs, and ensure that your business meets customer demand efficiently. Collaboration between domain experts and data scientists is crucial for the success of such a model. Thank you.